Hi, my name is Scott and I'm an engineer here at Agilent. Today I'm going to be demonstrating the M1970 Harmonic waveguide mixer. Now, this mixer is faster to set up and much easier to use than legacy mixers. For the setup, we have the PSG signal generator that is outputting a signal at 60 gigahertz. We also have the PXA signal analyzer with an external mixing option. Finally, we have the Smart Harmonic mixer. There are going to be two demos that I will perform for you today. The first one will show you how easy it is to set up the system. The second will show you how the power in the LO will automatically adjust to compensate for loss in the LO cable. The first step in connecting the mixer is to plug in the LO cable into the IF and LO input on the mixer. Next, simply plug in the USB cable on the signal analyzer. Now, the signal analyzer will automatically detect the center frequency and the span of the mixer, and it will start aligning the LO. Now, what it is doing is it's compensating for any loss in this IF and LO cable and making sure that the power level is adjusted to be consistent across the entire frequency span relative to the entrance at the waveguide entrance. Now, when it is finished aligning, the mixer is all ready to make measurements, and that's how easy it is to set up and use. Next, I'm going to show that the Smart Harmonic mixer is more accurate than legacy mixers. So first, I'm going to turn on a 60 gigahertz continuous signal, and what you will see on the PXA signal analyzer is this 60 gigahertz signal along with the mixing products. The reason for this is that the Smart Harmonic mixer is not pre-selected. Now, we do have a function that will get rid of these mixing products, and that is called Signal ID. So we simply turn on the Signal ID function, and all we can see now is the signal that's coming from the PSG. So next, I'm going to center on 60 gigahertz and add a marker, a delta marker. Now, what I want to show you is how the power level of the LO is automatically compensated for any loss in that LO cable and in the path to the waveguide entrance. To do this, I'm going to take a 3 dB attenuator and stick it in the path of the LO. One advantage of the Smart Harmonic mixer over legacy mixers is that it has much better conversion loss values. As a result, the Smart Harmonic mixer has better accuracy and sensitivity than the legacy mixers. Now, before I can account for the power loss, I have to realign the external mixer. So to do this, I simply go to our alignments and I just hit external mixer, and now we wait for the mixer to align. Now that the LO is finished aligning, we still have one more step. We have to account for the loss in the IF path. Now, the reason why we do this is we are using a single cable for both the LO and the IF signals. We do have a way to do this, and we have to enter it manually. So we go into external mixing to cable IF loss, and we enter the extra 3 dB of attenuation that we put in. And as you can see, the level of the power at that point is now back to the place it was when we started. And therefore, the Smart Harmonic mixer was able to automatically compensate for the loss in the LO cable due to that 3 dB attenuator. Today I've shown you how easy and fast it is to set up and use the Smart Harmonic mixer. I have also shown you how accurate it is compared to the legacy mixers due to better conversion loss values and the auto power correction for the LO. You can access more information about the Smart Harmonic mixer from the URL shown. Thank you for watching today's video.